Everyone, please pay attention. Pay attention, sir. Someone is behind you.
Sorry.
If you don't mind sitting, thank you. So, trigonometry has started already. Now, we have gone beyond numbers, algebra, which we ended with graph, and now it's trig. But this trig that I want us to focus on for now is on the graph, because the graph aspects are related. But I thought the idea of sine, which you might think is called sin at first, is probably new thing to everyone. I'm not sure if that's true, if some people have done something like sine cos tan before. Anyone? No, okay. So let's assume it's new to almost everybody. So that means you will be confused when I start talking about the graph of sine, graph of cos, even though you understand the concept of graph and solving equation with it. So we might as well just explain that first. That's why I thought, okay, let's do this. We call these trigonometric ratios. What did I call them?
Trigonometric ratios.
Trigonometric. Trigonometric. Say that. Trigonometric. Ratios. Simply put, we just say trig ratios. Okay? We call them trig ratios. Now, from the way it sounds, ratio means something divided by something. Right? So it means they are related to when something is divided by something. But in this case, the something that is divided by something are just lengths of sides of a triangle. Okay? So that's why I started with this idea. What are trig ratios? Okay? They are the ratio of any two sides of a triangle. Any two sides of a triangle. There are three sides of a triangle, right? When you divide them, you get a particular ratio. Maybe you pick the longest side and the shortest side, that's one ratio. You can pick the shortest side and the longest side, you get another ratio. That's if you flip it around, right? So there are 6 combinations of those things. I can do this divided by this. I can also do this divided by this. That's 2 now. I can do this divided by this and the other way around, making 4. I can do this and also this, making 6. Alright? But for IGCSE, we only discuss 3 ratios. Even in IB, unless you're an HL student, you are not going to hear about the other 3. Only HL student will talk about the other 3 trig ratios, making 6 altogether. So for some of you, you only need to worry about 3 of them that I'm going to mention today. Understood? Now, those 3 ratios are related to the sides of the triangle. But first, what do we call the sides of this triangle? So we have new terms to learn. Hypotenuse, opposite, and adjacent. I like to arrange it in this order for a particular reason. Again, hypotenuse. Everybody say that.
Hypotenuse.
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 Just like your Pythagoras theorem. I know you all write a squared, b squared, c squared. But I was trying Pythagoras theorem with h squared is equal to o squared plus a squared. That is hypotenuse squared, opposite squared, adjacent squared, something like that. So hypotenuse, opposite, and adjacent. Now the question is, what are they? Who are they? As the case may be. Now this is a right angle triangle. Again, this is for right angle triangle. Understand? In any right angle triangle, the hypotenuse is the easiest to identify, because it's the side facing the right angle. So this is my right angle, then this is my hypotenuse. This is the right angle, 90 degrees, facing it is the hypotenuse. This is my right angle, then this is the hypotenuse. Understand? And it's always the longest side. Can somebody tell me why hypotenuse must always be the longest side? Anyone? One simple reason why obviously hypotenuse should be the longest, based on what I've just said now. Anyone? Any idea? We have about 25 minutes or less. Yes, sir.
Is it because it's the sum of the other two?
It's actually not the sum of the other two. I'll give you one instance. By Pythagoras theorem, this is a valid right angle triangle. 3, 4, and this will be 5. Right? Because 3 squared plus 4 squared will be 25, which is 5 squared. Agree? But 5 is not 3 plus 4. Do you agree with me? So it's not the sum of the others. It's usually less than the sum of the other two. That's one inequality identity or whatever. But nice try. Anyone else? Okay, this is the reason. You see, as this, come here with me, everybody. Like, focus on this one. You have a straight line, yeah? You have a straight line. If I break it in here, and I try to form something like this, or better still, let's start from, okay? This is a particular distance, so let's say it's the third one. You will notice that if I continue to expand it, this becomes bigger. So I'll end up having something like this at some point. The smaller this angle, the smaller the gap. The bigger this angle, the bigger this gap. Understand? The same thing happens here. This one, the smaller this one, the smaller this will be. The bigger this one, the bigger this will be. In any triangle, the longest side is always facing the smallest angle, or the largest angle. And the shortest side is always facing the smallest angle. So there is no way this will be 90. Definitely other two. Are they less than 90? Is there anyone that can be more than 90? Because the sum of these two must be what? 90. So both of them must be less than 90. It means this is the biggest of all the angles in the triangle. Then this must be the longest side among all the three sides. If this is A, this is B, and this is C. If this is 60, this must be 30. It means the biggest one is what? Side. The biggest one is what? A, followed by B, followed by C. In that order. So hypotenuse is always the longest side in any triangle. Okay? So let's move on. Now we have seen how to identify hypotenuse. It's the side that faces the right angle and is always the longest one. Okay? Now which one is opposite? There will be a given angle, a given acute angle. This time around I call it theta. It's the popular Greek letter that we use. Theta. Everybody say theta.
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 So that's the Greek letter theta. Actually, this is the lower case of theta. Just like we have capital letter and small letter in English, the Greek also have theirs. Have you seen this before? What else was that? Sigma. This is also sigma. Uppercase and lowercase. Understand? Have you seen this before? That's the alpha, right? Beta. What's the next one? Gamma. Delta. Epsilon. Okay? At some point you see this guy omega. Those of you that in Christianity, you talk about alpha and omega. Have you heard of that before? Alpha and omega. We usually use that to say the beginning and the end. Is that not? Is that not?
Yeah.
In Christianity. Because alpha is the first Greek letter and omega is the last Greek letter. That's why when we describe God in Christianity, the God is the beginning and the end, the alpha and the omega. It's from Greek letters. Alright. So these are Greek letters just like our normal English letters. Lambda, epsilon, and so on and so forth. Interesting guy. You should check them out on Wikipedia. You should learn to know them. They are good friends. They love you. I'm sure you love them too. think I'm crazy? I'm not. I'm fine. And then, oh my God, Mr. Daniel is befriending Greek letters. Are you sure he's not saying things? I'm not saying things, okay? I'm saying myself. You don't believe me?
Yes, no.
All right. So opposite is that side that faces the angle that we are discussing. The angle in question. Remember, it's a right angle triangle. So angle 90 is not the angle of reference, because that will always be there. But we are going to now identify one given angle. It might be given in the question, it might be found in the question. So there will be an angle of reference, and it's always less than 90. That particular angle of reference, any side that is facing it is your opposite. So in this case, our angle of reference is theta. Then this becomes our opposite. Our angle of reference is theta. Then this becomes our opposite. Our angle of reference is theta here. Then this side becomes the opposite. Once you identify your hypotenuse and opposite, the third one is your adjacent. Okay? The adjacent is not the side that the triangle sits on. That was one misconception I had in my high school days. That, oh, the adjacent is always this one. It's like, oh, it's sitting on the adjacent. No. Okay? Actually, someone once told me that, and I believe it. So, when I became older, I realized maybe some triangles don't like sitting. They might be standing on one leg. So what is the adjacent? Their legs? Do you understand? So what happens if the angle in question is here? This is opposite, this is adjacent. What if the angle in question is alpha? Then this is the opposite and this is the adjacent. So the adjacent is now the head. Do you understand that? So just identify your hypotenuse, identify your opposite, and the third guy takes the last one, the adjacent. Okay? So do not forget this. Hypotenuse, opposite, adjacent. So we usually just use the first three letters, HIP, OPP, and ADJ. You can use those short acronyms as well. Okay, moving on. Aside for IGCSE, you only discuss three ratios in relation to the angle theta. It's because I'm talking about theta all along. If I'm talking about angle x, it will be in relation to angle x. If I'm talking about angle alpha, it will be in relation to angle alpha. This is just a variable. But theta is like the most popular variable for angle. Just like, what is the most popular variable for unknown in math? X, most popular. I need one. X. Okay? So the same way when dealing with angle, 99% of the time people will say let the angle be theta. It's always like that. So theta is the angle of reference. Now I said these ratios are called sine, cosine, and tangent of theta. Now I'm defining the trig ratios proper now. The trig ratios are called the sine, cosine, and tangent of theta. Or simply put, we just say sine theta. We don't have to write sine in full. Cos theta, we don't have to say cosine in full. And tan theta, that's why your calculator only have three letters, sine, cos, tan. Can you see them on your calculator? Look at your calculator, everybody. Can you see them? Okay, all right, and they're neighbors. So they live next to each other. They're neighbors. Maybe they watch each other's kids, who knows? Okay, now, what do they mean really? Look up, this is the last part now. The trig ratio sine, cos, and tan can be remembered using this acronym. This is how we learn as well. Sohcahtoa. Everybody say that. Sohcahtoa. Sohcahtoa. Once you remember this acronym, you don't have problem even in future trig topics. What does Sohcahtoa mean? It simply means sine theta is opposite divided by hypotenuse. Cos theta is adjacent divided by hypotenuse. Tan theta is opposite over adjacent. This is what it means. So the ratio of opposite divided by hypotenuse is actually the sine of the angle in that triangle. That's what we are saying. The ratio, when you do adjacent divided by hypotenuse, maybe the ratio is 2/3, then that tells you the cosine of that angle in that triangle is 2/3. Am I making sense? The ratio, when you do opposite and you divide it by adjacent, what you have just found is the tangent of that angle in that triangle. how to use this, it will make more sense to us very soon. Does this make sense for now? So for now, I just want us to identify, familiar with this terminology, sine, cos, tan, for now. Because of what we are doing right now in that graph paper. So let's quickly finalize the graph. Then by the time I come next time, we'll just apply this immediately. I'm not going to go into that calculus immediately. We're just going to apply it because we have now talked about it. So it makes sense to just go through with this immediately. Understand? So I want to show you something. Before then, from your observation, what do you notice about the sine graph? You plot it yourself. What do you notice? Or what is the difference between your sine graph and your cosine graph? Anyone? Sine graph and cosine graph. What is your observation? What do you notice?
2 turning points for the sine graph and 1 turning point for the cos.
You can't really say that. Actually, okay, wait, maybe within the range. Within the range of angle, what and what? 0 and
360.
okay, so that's one observation. Any other observation, please? Yes, Mr. Juvino? Speak up and fast,
The
please.
cosine graph is just the sine graph, but like offset.
What?
The
Juvino, I need response fast because we have no time.
cosine graph is just the sine graph, but like offset by 90 degrees.
Did anybody hear the last part? But also what? You need to speak clearly. The same way you started clearly.
Offset by like 20 degrees.
Opposite or offset or what?
He said offset by 90 degrees.
Offset by 90 degrees. Not so sure what you meant by that.
Like
to the side.
it's shifted.
Oh, it's shift by 90 degrees. Okay, okay, I can give him that. Any other one? Observation quickly. Yes, Mr. Whitechuck?
Like for sine, it starts and ends with 0, and for cosine, it starts and ends with 1.
Can you give him a round of applause? That's the main thing you need to remember. Sine graph starts with origin, 0. Cosine graph starts from 1. That's the major difference. Okay? Of course, every other thing you have observed also is true. But this is the major thing that I want us to focus on. Understand? Then also, there's some other thing you need to remember that you should notice there. What is that similarity between sine and cosine graph? There's something common to both of them. Look at that, those two shapes very well. There's something common to both of them. Yes, Jubino?
It's a wave.
It's a wave. Okay, I give you that. Apart from that, have you done waves in physics?
No, not yet.
Not yet. So watch out for these things when you get there. Okay? Yes, what else? Can you focus, please? This is not laughing time, Mr. William. What else? Look at this too. There's something. Okay, go to your tan graph. Then you will notice something that both sine and cosine graph has that tan does not have. That is not the correct tan graph, by the way. Okay. Yes, anyone? You raise your hand, mister. Were you raising your hand, mister? No. Okay, you? Yes.
It's one consecutive line.
Say that
One
again?
consecutive line.
What?
It's like one line. Well, this has 3.
One line. What do you mean? There's no line there. Can anybody see a
I
line?
mean like one curve.
Curve. So it's a continuous curve. Both are continuous curve, but tangent is not continuous, right? Because it breaks at where? At every 90 degree. It breaks at every 90 degree, right? But that is still not what I want. But of course that's correct. What else? Yes, sir.
They will have the same minimum.
The same minimum point? What do you mean?
Like they won't consider minimum.
Minimum, what do you say? Not minimum point.
Maximum?
Really? -1 is your maximum?
No, the one.
The fact that it's not minimum doesn't make it maximum. Just try to listen to what it's trying to say. He said but they both have the same minimum point, and I disagree with how he put that. But I have an idea what he's trying to say. Yes, sir.
They both remain between -1.
they both remain between -1 and 1, your sine or cosine cannot go beyond -1 and 1. Now everybody bring out your calculator. Think of any value of your choice, no matter how huge, and press sine of that value. Think of any value, be it positive or negative. Remember to put it in brackets, for negative especially. Think of any value of your choice. Put it in your calculator. You can play around with about 6 different values. Big, small, you know, positive or negative. Tell me if you get anything that is beyond 1.
Math error.
Where do you get math error?
Too big.
What do you mean? It's working.
No, one extra digit. And it's
Check it again. It should not be too big. Okay, maybe your calculator has a limit then, but that's fine. But for the ones that you are able to get, did you notice anything 1 point something?
No.
Minus 1 point something?
No.
Your sine and cosine is always between 1 and -1. So when I get to the next topic, and I'm trying to find angle theta, and you have something like sine theta is equal to 1.1, there's an error. You can never get the angle theta because there's no angle like that. Your sine and cosine are always between 1 and -1. What I expected to say was minimum value, not minimum point. Okay? Both of them have minimum value of -1 and the maximum value of 1. Remember, the value is the y. Understand? The point is the xy coordinate. Do you understand what I mean now? Okay, great. Now, let me now show you what I want to show you based on the fact that you have done your thing. Lights off, projector on. Projector on, please. Silence. If you are that restless, mister, please, you may leave the class.
Do I leave the camera on?
Yes, sir. I'm but on the screen. Come on, Mr. Epstein. Exceed your vision. You're wasting time, bro. Yeah, it's just wasting time. Exceed your vision.
That's facts.
I don't want you to exceed our vision. Let's project this stuff. Searching for all sources. It's right here, dude. I'm ready when you are.
I think we should put this first.
Might use it on Friday. Did I plug in the wrong thing?
Not the power line.
Something is about to happen? No.
Yeah, what you
Good
do?
job, Solon.
That was so long.
Aye, good job, Solon.
So that'll be good.
I'm just set up.
No.
The action was like
Okay.
Okay. I might have put in the wrong stuff. 1 sec, please. Put it on 12:07. I have 5 minutes. Okay.
For no future issues, I will.
That's what this works now. Drum roll, drum roll, drum roll.
Drum roll.
Okay, Harry Potter magic. Boom. Okay.
So blurry.
There's nothing we can do about that, sorry.
Right.
Okay, so this is it. This is what you have. Yes?
Here.
Yes.
You can see something else. Instead of 0, 30, 60, what do you notice? What's that?
Pi.
Pi. This is radian measure. So those of you seeing R on your screen earlier, you were working in this mode with this guy. When you leave IGCSE, you don't deal with degree anymore. In IB, we use radian measure for angles mostly. They're going to teach you. The difference is not much. Okay, everybody. Now the calculation, the conversion is this. Can somebody tell me what is in your graph paper at this point for sine? 180.
Yeah.
If you look before you speak, sir. 180, right?
Yeah.
180 degree is pi in radian measure. Just like when I say good morning or hello, in Chinese somebody will say ni hao, right? Is that hello, right? That's hello.
Yes.
Yeah.
Somebody will say hola, but you're saying the same thing. You're just speaking different languages. So in the radian country, 180 degree, the angle on a straight line is pi to them. But in our own environment, we say, oh, 180 degrees is a measure of the angle. It's the same thing. Let's test that. So I asked you to press something earlier, quickly. Press sine 180, quickly. That should be 0.
0.
Okay? Press cos 180, -1.
Yes.
Yes?
Yes.
Okay, now press sine 45. Are you taking note of this? Can you write it down somewhere so that you don't forget? Sine 180, you got 0.
0.7.
Sine 180, you got 0.
Yeah.
Cos 180, you got -1. Sine 45, you got 0.7. Yes?
Yes.
Cos 45 should be the same thing. I'll tell you why later. You got the same thing, right?
Yeah.
All right. Sine 30, 0.5. Check.
Yes.
Cos 30 should be 0.866 something. 0 or maybe 0.9.
0.86.
Okay, great. Now, I want you to press mode and change it to radian. So that would be shift mode. Can you leave the camera, sir, and focus on your calculator? Shift mode.
Yeah.
Then you will see the radian. Rad. What number can you see? Press it. Your calculator may be different. Convert it to radian. In your okay, done. Okay. Now you're in radian now.
Yes.
There should be R on your screen. Let me put this on. There should be R on your screen. Can you see?
Yeah.
Yeah.
Done?
Yes.
Now we're going to practice what you just did. Now I want you to press sine 180. Don't press anything apart from sine 180. Did you get your 0 back? Because you are saying different things to them. It's like going to Nigeria and tell someone ni hao, they're going to look at you like, what are you saying, dude? What do you want? Or do you want to rub me? Is that how you guys rub these days? Ni hao? I don't know what you're saying. Because they don't know what you're saying. Or me walking to a restaurant and asking them for amala. It's like, they're going to call each other. We don't know what this man is saying. Because I'm speaking a different language, in a different environment. That's what you just did. You're in a radian environment and you're asking for 180. You're not asking for 180 degree. That is something else to them. So if you want to ask for 180, you press sine and you press your pi. Pi should be a button on your calculator. That is shift times 10 something something in your calculator. I don't know what it is in your calculator.
Yeah.
So press sine pi is equal to what?
0.
Now you are speaking the correct language. Press cos pi and see if it is the same as what you did before. You got the same thing. Now, because pi is 180, 45 will be pi over what? Pi over 4. So press sine pi over 4, press cos pi over 4 and see if you get the same thing back.
Yes.
Yes?
Yeah.
Good?
Yeah.
Then we also checked 30 degrees earlier. 30 degree will be pi over 6. So check again. Sine pi over 6 and cos pi over 6. Did you get the same thing?
Yeah.
Yes. So this is the difference between the decimals and your table, your graph. Stop. So don't be confused. If you are working, we are using decimals to practice at home. Don't be confused. The only difference is this is not the measure that you are used to. Now everybody take it back to degree. Make sure your calculator is always in degree for the purpose of the exam. Take it back to degree. You know what to do. Shift mode and you press the number associated with degree. Now I want to show you something. So this is your sine. and this is your cosine. Yes? Okay, it turns. It's a periodic function. Periodic function means the exact shape repeats after a particular time. Both sine and cosine are periodic. Look, it repeats after 2 pi. So this one starts from here and here. You notice that the exact thing, I can cut it and paste it here and here, and it continues. After every 2 pi, I have exact same thing. We call such a function periodic function. Your physics teacher will mention that again later. I don't know, maybe with this level or next level. So they are both periodic functions. But let's see